So welcome my Year 9 new material students. Let's see if we can have that up properly. Here we go. Because I'm not there with you today, I thought I might leave a little bit of material for you guys to work with. So this is some equations that I've balanced, and I'll walk you through a few of them. I hope this helps when I'm not there. So, making silver. This is based on an experiment I used to get you guys to do, which we won't have time for, but we ran a few experiments and we tried to balance those experiments. So I'll do a couple of these and try and make sense of them. So for me, the best way of going about balancing an equation, especially when you've just started, is to write the equation out. So you've got your silver nitrate plus copper, and they react together to produce silver plus copper nitrate. So what have I got? I've got one silver on that side, one silver on that side. So far, so good. One nitrogen over here, but there's two over here. 3 oxygen, 6 oxygen. One copper and a second copper. Same copper. So that's all right. So copper and silver are okay, but my nitrogen and oxygen have been doubled. Now, interesting enough, you'll see here that the nitrate is the problem. We've got one nitrate there, but copper requires 2 nitrates. Silver is +1, copper is +2. Nitrate has an overall charge of -1. So we have a reason for that happening, as we discussed ionic and covalent bonds the other week. So I thought I had my solutions. There you go. So I thought I actually could have sworn I had solutions in here for you. No. Okay, that's all right. So what do I do? How can I go about balancing this out? Well, if I put a 2, I can read this now. I have to escape that. Hang on. If I put a 2 in there, I'll just make adjustments as we go. 2 there, I'll make it red. That'll give me 2 nitrates, which is a bit of a win for my nitrogen and sulfur oxygen problem. But it gives me another problem, doesn't it? I've got 2 here. So I can put a 2 there, and that would take care of my silver problem. 2 times 2, I've now got 2 nitrogens, and I've now got 6 oxygens. That's all okay. Copper's going to change? No, copper's going to be okay too. So that's what I need to do. To balance this equation, all I required was to acknowledge the fact that I needed 2 silver nitrates, and I had 2 silver atoms joined in a metallic bond, and then the nitrates are balanced. Okay. One of the other experiments that the students would do in that particular little session was to burn sparklers. Now, the thing that flares and gives all the light off, of course, is magnesium. There's a lot more other rubbish in there that we're ignoring, of course, but don't tell Lavoisier, and I won't. So here we've got magnesium being burnt with 2 oxygens, but producing magnesium oxide. So magnesium is 2+, oxygen in this case here as an O is 2-. But again, I've got a problem. I've got 2 oxygen on this side. So if I go simply put a 2 in there, 2 magnesium plus 2 oxygen, I now have the ability to make 2 magnesium oxides over there. So again, I'll just colour those so you can see them. I now have 2. Oops. I still have 2. 2 times O2 over there. I now have 2 here, and I have 2 there. So that's pretty straightforward, isn't it? Let's find some harder ones. Find one more hard one to hopefully help you with your work. If I close that, I won't save those because I've missed that one, hasn't it? Balancing equations. This one. The homework page. That's what I should have shown you. I had it all set up with the answers and everything. So here we go. No, I can't get to that bit. Let's find a little harder one, hey? There's got the answers in it. That's a nice one. I've got a bit of depth to it, hasn't it? So we've got 3 carbons here. This is ethene, from memory. Ethene and oxygen combusting to produce carbon dioxide and water as byproducts. So 3 carbons, 1 carbon. Whoops, I've lost 2 carbons. 8 hydrogen, 2 hydrogen. I've lost 6 hydrogens. I'm in big trouble here. 2 oxygen there, but 3 over here. So we're in real trouble. All 3 fail to balance. I can't change the structure of this molecule. I can't change the structure of that molecule. What I could do is put a 3. Oh, that results come already. I could put a 3 in front of the carbon dioxide, which will give me the 3 carbons balanced. I need to put a 4 in front of my water because I need 8 hydrogens. I've only got 2 here, 8 there, so 4 times 2 is 8. And that would give me then 4 oxygens and 6, so 10 oxygens. So I need a 5 in here to balance it out. Well, that has time going. I'll do one more. It's only a short little video, isn't it? So calcium chloride plus silver nitrate react to produce silver chloride and calcium nitrate. Calciums are okay. Chlorines, one too many chlorines on the left-hand side, so my reactants. Silver's okay. Nitrogens, nope, one too many nitrogens on the product side, and we've got far too much oxygen on the product side. So, how do we solve this? So, we'll press the button. Quite simply, 2 silvers, 2 Ag, so 2, back up, 2 silver nitrates, 2 Ag NO3s. So they've got 2 silvers, and now I put 2 on both sides. I've got 2 silvers on both sides. Now silver was okay, remember, before, and it still is. But I need to get to do something with chlorine, so I've now got 2 chlorines. So it solved my 2 chlorine to 2 chlorine problem. And I had an oxygen problem, but I've now solved that because 2 times NO3 is going to give me 6, and 2 times 3 over here is going to give me 6, and 2 times nitrogen, and 2 times nitrogen, so it all balances out. Hopefully, that's enough to keep you guys going with your homework. In fact, I think those 2 we've just done are off the homework sheet that you're working on, so there's a bit of a head start. Enjoy balancing equations. There's some extension ones there for those who really get the hang of it. And remember, Lavoisier was a taxman. He's an accountant. This is all about numbers. It's all about finding those patterns that make the numbers make sense. And the only numbers you can change are the big ones in front of a molecule. The molecule itself can't be changed. Okay? Good luck.